should draw it. Okay. So imagine we take triangle ABC and we flip it over. So we make a copy and then flip it over. Okay? It looks something like that.
Do we draw that? Do they draw that too?
Yeah. Yes.
I thought you had to do
So we just have 3, right?
no 4. I'm here, that's why.
So we've got our triangle ABC. Notice the altitude is drawn. So we're going to take our triangle ABC and just
Flip
make a
it.
copy of it, right? Reflect it over here. Okay.
And it makes
Now,
a
what would
parallel-
happen if we slid these two triangles
It
together?
makes a parallelogram.
We would get a parallelogram. Okay. Get a nice, beautiful parallelogram. Now, what is the area formula for a parallelogram? Base times height. We saw it yesterday. So we have the base times the height. That's the altitude of the original triangle, right? And so, how much of the parallelogram is a triangle? Half. So the area formula for a parallelogram, or I'm sorry, for a triangle, area is a half of the base times the height. Okay, so that's where that formula for triangles that you've been working with since 3rd grade, that's where that's coming from. It's the area of a parallelogram cut in half. And that will be any triangle. Any triangle you can think of, you can flip it over and then put it together and make a parallelogram. Yes. Not right now. To find the perimeter of a parallelogram, of a triangle, find the perimeter of a triangle, we just add up all 3 sides. Okay. So look at the first example. We're going to find the base, the height, the area, and the perimeter of this triangle. So the base of a triangle is just like that part of the
8.
parallelogram. So in this case, the base is 8. All right, so that's like the bottom. Notice the height is perpendicular to the base, always.
So it's 3.
So the height is 3.
Oh, 7.5.
Now using the base and the height, we can find the area of the triangle. So the area will be 1/2 times the base times the height. Now you may have seen this formula before as base times height divided by 2. Right, BH over 2. That's the exact same thing as 1/2 base times height. Exactly the same. Okay, so you've seen it as BH over 2. That's the same as 1/2 BH. It's the exact same. And so we get an area of 12. The area of that triangle is 12 square units. Now to get the perimeter, we need to add up our 3 sides. We know all 3 sides of this triangle. No, we're missing a side. I'm going to call that side for right now Z. I don't want to call it X.
Can we
We'll
call
call
it
it Z.
C for Z?
Now, notice that that side is the hypotenuse of a right triangle. So what tool do we have in our toolbox that will help us find the missing side of a right triangle? Okay, SOHCAHTOA would be useful if we have an angle, right? But we don't have any other angles besides the right angle. And what's that called? The Pythagorean theorem. So if we know 2 sides in a triangle, we can use the Pythagorean theorem. Do we know 2 sides of my red triangle here?
3 and 8.
Well, we know this side is 3. Is this side 8?
No.
No. So the whole thing is 8. This part we aren't sure of. So we need to find this side. Right? If I know this side, then this side plus this must equal 8. Right? Well, we've got another right triangle. Do we know 2 sides of this right triangle? Okay. And so I'm going to call this side X. So how the heck can we find X? What do we need to do? Well, let's hear. Let's think about this for a second. We've been using the Pythagorean theorem for a while, right? A squared plus b squared equals c squared. So, as a side note here, let's think about this. If I have a squared plus b squared equals c squared, and I want to find c, I want to solve for c. What would I do?
You use the hypotenuse. Yeah. Add A and B.
How would I solve this equation for c?
You plug in the numbers.
Nope. How would I solve for c?
Add A and B.
How do I get rid of the square?
Divide c squared on both sides.
Square root both sides. All right, so the square root of c squared is c. So C is equal to the square root of A squared plus B squared. So if I'm looking for the length of the hypotenuse, it's the square root of the square of the two sides added together. Okay? What if, go back to the original Pythagorean theorem, A squared plus B squared equals C squared. What if I'm looking for, say, A?
C squared minus B squared.
So we would subtract B squared from both sides. And so we had A squared equals C squared minus B squared. And then how would we solve for A?
A equals square root of C squared.
So we square root both sides, so we get A equals the square root of C squared minus B squared. Okay? So we can actually use this. If we're looking for the hypotenuse, we don't have to write out the whole Pythagorean theorem and take 4 steps to do what we can do in 1 step. If we're looking for one of the legs, we don't have to write out the whole Pythagorean theorem. We can just jump straight to the conclusion here. So to find x, is x a hypotenuse or a leg here? So it's going to be like the A here. Notice A could be either side of the triangle. It doesn't matter. It's just one of the
A
two
could be
legs.
4.
So in this case, x equals the square root of 4 squared minus 3 squared. So rather than writing out the Pythagorean theorem and doing this in 3 steps, we can do it in 1 step. It's a shortcut. So we do the square root of 4 squared minus 3 squared, which is equal to, and this is where the calculator comes in really handy.
36
Not
take
five.
away 9. 36 take away 9. No. I mean 8.
Calculator one column. 2.6457.
So we get 2.646. Right? So 2.646. So this length right here is 2.646. So how long is this length right here? How do we get it? Subtract. So 8 minus 2.646. Okay. And we get 5 point what? 354. Okay. So now we can find the actual length we were originally looking for. We can find this side right here, Z. So Z is the hypotenuse of the triangle. So Z will be the square root of 3 squared plus 5.354 squared. Again, we're just using our Pythagorean theorem here. Section outcome. So everyone should have their calculator open at this point and should be calculating these on their own. And just confirming the answer that I guess the first person gets. .1345, so 6.135. I like 137 better. Okay. Now, what was the purpose of finding that? What did we just find? We found this length right here. So this is 6.137. So to find perimeter, we add up our 3 sides. So our perimeter, well, let's see here. This side was 4. This side down here was 8. And then this side we just calculated as 6.137. And so we get a perimeter 12 plus 6.137 gives us 18.137. Our base, we got our height, we got our area, and we have our perimeter. Okay. So notice we had to use the Pythagorean theorem twice here to find various parts of the triangle. You guys have been finding areas of triangles since 3rd grade. You just haven't had to find a whole lot of missing information in most of those problems. In middle school, you had to find some using Pythagorean theorem. And then now we're going to also have some additional stuff. So, for example, 2.
That's a lot
So
of work.
same problem. Find the base, the height, the area, and the perimeter. So what is the base of this triangle? It's 4. It's this whole side right here. Okay. What's the height of the triangle? What's the height of the triangle? It's unknown. So we want to look at it and say, well, what do we know that we can use to find the height? And we've got two sides of a right triangle. Everybody see the small right triangle here? All right, so I've got this right triangle. I know this side is 2. I know this side is 7. And so Pythagorean theorem. Now are we looking for the hypotenuse here? No, so we're going to find the square root of c squared minus b squared. So 7 squared minus 2 squared. And so we put that into our calculator, square root of 7 squared minus 2 squared. We evaluate that.
6.708.
We get a height of 6.708. So we've got our base, we've got our height. Once we have base and height, we can find area. So area is 1/2 times the base times the height. So 1/2 times 4 times 6.708. And then finally we want a perimeter. So to get the perimeter, we add up all 3 sides. So this side was 4. This side is 7. And this side is 7. And so we get a perimeter of 18. And then our last example. Let's see here. We've got a base. Now, on the last problem, on example 2, the base was already broken into 2 parts. So we just had to put 2 and 2 together to get 4. In this case, the base is also broken into 2 parts. But this time, it's 8 square root of 3 divided by 2 and 2. But we find the base the same way. We add those 2 together. So 8 square root of 3 over 2 plus 2. So since we've got 2 measurements on that side, then that's our base, and we add them together. And so we can use the calculator to get an approximation for that. It's labeled on the picture. We're using the labels on the picture.
57.425.
Look at your 8, John. 8.928. You have 8 squared times square root. Okay, so 8.928 is our base. What's our height?
We don't have it.
Don't know it yet. So we've got a 30-degree angle marked. Now there's a 30-degree angle there, which means that we can use what from all of our available tools? We can use trig. We can use our trig ratios. We can write down SOHCAHTOA. What's something else we can pull from our toolbox? The 30, 60, 90 triangle. If we see a 30-degree angle and a right angle, this must be 60. And then the shortest side in the triangle will always be how much of the hypotenuse? Half. So how long is this side? And then we know this side is actually this times the square root of 3. So how does that relate to what it's labeled?
So you do 4 times square root of 3 divided by 2.
What is 8 divided by 2?
Oh, that's
4. So this actually is the exact same thing as 4 square root of 3. Okay, so this is 8 root 3 divided by 2 is 4 root 3. Okay. So what's the height of this triangle?
4.
Okay, so we've got a base, we've got a height. We can find the area. 1/2 times base, so 8.928 times height of 4. Put that into our calculator. 14 point something. And we need our perimeter. Can we find our perimeter right now? No, what's missing? This side right here, right? So we'll call that, I'll call it X. You can call it whatever you want. You can call it David if you want, doesn't matter. Okay, but it's the hypotenuse of a right triangle. Alright, so X will be the square root of 2 squared plus 4 squared. Oops. And so we get a length of 4.472. Double check that. So this side right here is X is 4.472. So to find our perimeter, we just add up our three sides. So 4.472 plus 8 plus, and then what's the third side? 8.928. And so we add all of that up, and we get a perimeter of 21.4. Now notice on the problems where something's missing, you pretty much have three things that are a possibility for these problems. One would be what? What's one of the tools we used to find a missing side? Okay, one was Pythagorean theorem. Okay, what was another tool we used? Trig. We didn't actually use trig here though directly, right? But trig would absolutely be an option. If you don't remember, what's the third one? The special right triangle, right? So 30, 60, 90, and 45, 45, 90. You don't have those, if you don't remember those, you're not seeing the connection, then revert back to SOHCAHTOA, and it'll work just the same way. You'll get the exact same answer. It'll just take you just a couple more steps. Okay? Kind of like if you don't like this shortcut, don't use it. Go back and just label your sides A, B, and C, and use the Pythagorean theorem. There'll be a couple more steps, but you'll end up with the same answer, and I'm perfectly fine. If you don't like the shortcut, don't use the shortcut. Okay? Are there any questions on these three examples? Sure. Okay, so there are 10 problems. 10 problems. You have 35 minutes to do these 10 problems, which gives you over 3 minutes each. So do your best to finish during class. Don't finish your homework. There will be a quiz tomorrow over the 3 lessons we've done so far. So rectangles, parallelograms, and triangles. Make sure that you're able to do one of each. Okay?